Okay, probability grade 12. Yes. There's two parts. There's Venn diagrams, there's tree diagrams. That will be one question. That comes from grade 11. We can always go back and recap that. Um, the part we're starting with today is called the identities. So the identity that I'm dealing with is identities is it's really important because we need to know a few of them. The first one that we'll start with is P. We're going to start with P, A or B. Now, P, A or B just means either. So this or could mean either. I'll show you guys what it means now. But this equals to PA plus PB, and that's minus P, A, and B. Okay. Now, what does this mean? Realistically, this is the probability of total A. It's the total of A. This is the total of B, and this is both. Now, if I had to draw a Venn diagram to try and teach you this, or if I had to draw, this is more of the addition rule, so it's a little bit easier. But if I had to draw a Venn diagram, this only works when stuff is not mutually exclusive. Now, what does that mean? I'll teach you about mutually exclusive now, but there's it there, and okay, let's move there. Let's just say probability of somebody that likes, the probability of somebody that likes dogs, the probability of somebody that likes cats. This is 100. I'm using random numbers. I don't really like cats, so I'm making them 10. And this is 20. In terms of a Venn diagram, just to remember, this is the total. You could watch the other videos and learn from it. This is the total. That means the total people we interviewed or the total people we worked with. This is the people that don't like cats and dogs, but it's not about cats and dogs. These are the people that like none of the options for A and B. I want you guys to understand the probability. This is the people that like dogs only, the people that like cats only, and the people that like dogs and cats, or just dogs in general. Let's say dogs in general is this circle here. The people that like cats in general is this circle here. And the people that we need to memorize properly, the people that like dogs and cats. So this is and, right? That's and. And this is or. So this is or. So when you see the word or, it's talking about all the people in the data, not excluding the people that don't want to be a part of the data. Now, it might be complicated, but an example would be the probability of or. Let's talk about the probability of A or B. Now, A or B, I can look at this and I can see, hey, 50, 20, 10, that's 80 out of 100 people like cats or dogs, which is 0.8. But this is just a recap. You can find a full video for the grade 11 one, or grade 10 actually. But what happens when we want the probability of A or B properly without a Venn diagram? You can take the probability of A plus the probability of B, and you minus the probability of A and B. Now, what does that mean? That means that we take the probability of A. How many people like dogs? That will be 70 over 100. I'm going to use 0.7, guys. 70 over 100 is 0.7. Plus, the people that like cats is 10 plus 20, 0.3 over 100. Sorry, 30 over 100 is 0.3. I'm making these questions up. And minus PA and B, which is PA and B is 0.2. And this will definitely equal to 0.8 or 80%. Or 80 over 100. But if you didn't watch the grade 11 video, then I understand it's going to be a problem. But that's the first identity that we need to know. And this only works if it's not mutually exclusive. Now, we're going to try and do this in two parts, but not mutually exclusive. Let's go and talk about what does mutually exclusive mean, okay? Now, mutually exclusive means something cannot happen at the same time, okay? So it cannot happen at the same time. Now, again, if it cannot happen at the same time, the circles will look a little bit different. So the circles that we get when things don't happen at the same time is something that looks like this. The circles will never touch. So for now, it's just the theory that you need to learn. Let's talk about left and right. Or let's talk about up and down or whatever. But if you were turning left, you can't turn right at the same time. If this person was just walking straight and they needed to turn either left or right, they would have to make the decision to go one side. They could not turn left and right at the same time. Now, mutually exclusive means that it cannot happen at the same time. It is absolutely impossible. We need to remember that A and B will be equal to 0. So you will never see the probability of A and B because it equals to 0. It can't happen. Impossible. Okay? So it's impossible and it should be fine. Now, we have a different addition rule because, again, this is one important one, I understand. This one is definitely coming out in grade 12. But the next one is to understand that when stuff is mutually exclusive, right? When stuff is mutually exclusive, we need to say that P, A, or B equals to PA plus PB. Because there's no and, all we have to do is we have to go and remove the and. Because mutually exclusive means there's no and. It's just the two things that matter. So turning left or turning right. There's no turning left and right at the same time. That's the second formula that you need to memorize. You also need to understand it and when to use it. And if you don't, we can work on that. But this is complementary. Okay. Now, complementary is a little bit different, right? We can work with the complementary rule, but we can also work with the not rule. We need to understand the not rule is very, very, very important. Okay. Let's talk about the not rule. Now, when it comes to complementary means that PA plus PB equals to 100%, 1. There is no other options. PA plus PB equals to 100%, and it has to be mutually exclusive. Okay? Now, let's try that again. Let's draw our circle. My circle is not circular, but guys, deal with it. A and B. Let's make this 40. Let's make this 60. And let's make the total 100. Complementary means that this A and B together will be 100% no matter what. There is no other part. There's no part here that states no one is allowed to join. Okay? So there's no part there, or there's no part that states that these people are not part of the situation or not part of the survey. So we need to remember complementary means that A plus B is 100%. So it means these two circles are all there is for the data. It will equal to 100%, and they are definitely not touching. Now, when we deal with complementary, we can deal with the not. The not law is very important. Not. So guys, let's talk about some silly fruits. Let's call this apples and bananas. Let's say there's 100 people, 100 surveys done, and people either like apples or they either like bananas. They don't like both, the people we interviewed. So when we talk about not, the not sign is shown with a small apostrophe. Just like calculus with the apostrophe, the not sign is shown with an apostrophe. So that's what not A means. This is how we show not B. Now, what does not mean? If I said calculate the probability of not bananas. So if I calculate not bananas, automatically we know the answer is apples. So the probability of not bananas would be definitely equal to apples, right? And the probability of not apples will definitely be equal to bananas. But now we need to figure out how to calculate it. What is the proper calculation? So I'm not going to do the probability part, but I am going to do the how many part. If we wanted to find out what's not bananas, all we had to do is take the total 100% and minus the bananas, which is 60, and that equals to 40. So now we know the probability of not bananas is 40. The probability of not apples is 100 minus the apples, and that would be 60. So let's go and learn a proper formula. I promise there's only two more. But the probability of not A has to equal to 1 minus the probability of A. So guys, basically, if they want you to calculate the probability of not A, just take 100%, 1, and minus the probability of A. Because you need to remember in probability, we deal with decimals, we deal with fractions, and we deal with percentage. But I said decimals for that one, but we deal with percentage, right? So these three are all fine. 100% looks like this. Oh, a fraction 100% would be 1 over 1, and a decimal 100% would just be 1. So it takes some practice. It's not easy, but there is a lot of calculations that you and I can do. We can practice with a lot of work to try and get this done properly. Okay. Now, if we move on, the last one, right, is the product rule. We need to understand the product rule when things are complementary. We need to remember that if two events are dependent, this is very important. When the events are dependent, you're going to see this one a lot, right? We're going to say P, A, and B does not equal to PA times PB, okay? So dependent means, guys, if you had two events, like going for your learners and your license, you cannot get your license if you don't have your learners. That's what it means. Independent means you are writing your probability exam on Thursday this week, and you have to have, I don't know, jungle oats to pass. It does not matter. One event does not depend on the other event. I mean, unless you need jungle oats to pass, but I don't think you do. But guys, realistically, dependent events, the two events depend on each other to happen. Independent means it does not. Okay? So, of course, now, independent would be the opposite. Independent would be the opposite. Now, I know this is not taught in detail in school, so we're trying to do it now. But PA times PB. So now we know that if stuff is independent, PA and PB will be equal to PA times PB. And I will do an exercise lesson on this, but okay, guys, this is an exercise on dependent and mutually exclusive. I didn't record this part, but we'll do an exercise lesson for this. Is from grade 11. We're using a textbook, the government textbook and government worksheets, but let's start with some really easy questions. It says, write down which of the following events are dependent and which are independent. So let's start. For question 1, it says the student council chooses the head student and then the deputy head student. Is this dependent or independent? That's the question. And the next one is a bag contains blue marbles and red marbles. You take a red marble out of the bag and then you throw it back in again before you take out another marble out of the bag, if I'm not mistaken. Yeah, another marble out of the bag. Okay, guys. So dealing with questions, I guess my students did answer. One student quite well. So we look at this, right? And we have to look at the first question we ask ourselves is, did the choice of the first event affect the choice of the second event? Right? Did any of the choices change because of the first event? Again, did any available choices change because of the first event? And we can say for the first one, yes. Because everyone in the first event voted for the head student or the head prefect or whatever you want to call them, there's fewer people left to choose for the deputy position. So we got this head person, we got this deputy people. And if you vote for the head person and take the head person out, for the next vote, there's fewer people to the thing. So there's only 2 people left to vote. I'm not saying there's 2 only, but I'm saying there's 2 people left. The choices changed. Therefore, these events are dependent. Because once you vote for the head girl or head boy or the head prefect or whatever, they are taken out of the equation. They're taken out of the probability and they can't be voted for deputy unless they're really good. But the jokes aside, this is dependent because the choices change. Okay. Now, if we look at the second one, I would say no, it's not dependent, right? This is more independent. Why? Because the choices do not change for the second event, right? Because they put the first marble back into the bag. So no matter what happens, the first event does not influence the second event because the marble is put back into the bag. But that's what dependent and independent means. Now, guys, this is all level 1 questions. We'll get to level 2 and level 3 very quickly. Most of this can be answered, but we're just doing a quick recap. Let's go with the next part. It says a bag contains 3 yellow and 4 black beads. Let's try and draw this. Makes it easier for me. 1, 2, 3. 1, 2, 3, 4. We remove at random a bead from the bag and record its color, and then we put it back into the bag. We then remove another random bead from the bag and record its color. Now, the fact that they put it back to the bag, that means no choice has changed. So this is most likely independent because the first event did not affect the second event. Okay. What we're going to do is we're going to start to answer. What is the probability of the first yellow bead? It would be 3 yellow out of total of 7 beads. So 3 out of 7. Right? To write out this properly, please understand this would be probability of yellow is equal to 3 out of 7. What is the probability of the second black bead? Now, because this was independent, the black bead is still 4 out of 7. Nothing changes. If it was dependent, most likely this would be 4 out of 6, but it's not. What is the probability that the first bead is yellow and the second bead is black? Quite simple as well. Please understand, for question 3, the probability that the first bead is yellow, then black, is quite simple. Because the probability that I get yellow on the first try is 3 out of 7. The probability that I get black on the second try is 4 out of 7 because I'm putting the beads back, guys. So what's going to happen is I'm going to take out a yellow bead. I'm going to take it out, and then I'm going to put the yellow bead back, and then I'm going to try and take out a black bead, and then put it back. So it's 3 out of 7 times 4 out of 7. And what happens is we end up with 12 out of 49. And the last question is, are the first bead being yellow and the second bead being black independent events? And I could see it's independent because we had a very easy way to deal with it, that no, nothing changes. But we can't just say that. You can't assume in probability. So we know PA and B has to be equal to PA times PB. Now, why is this mutually exclusive? Because you are taking out one marble at a time or one bead at a time. You cannot take out 2 at the same time. I mean, you physically can, but in this question, you're not taking out 2. So it's one marble at a time. Let's try. Probability of A is 3 out of 7 times probability of B. Oh, I put A twice, guys. B is 4 out of 7. And the probability of yellow and then blue, black, is 12 out of 49. And guys, we can see that 12 out of 49 does equal to 12 out of 49. Therefore, these events are independent. Okay, guys, we'll be dealing with the next part. So this is also part of identities. We're going to try and get to Venn diagrams and tree diagrams as well, just for a little bit, but let's try and get this done. The next question says, in the previous example, we picked a bead and we put the bead back into the bag before continuing. This is called sampling and replacement, right? Most likely that's called independent, right? It didn't change, but in this worked example, we follow the same process. The only difference is we will not put the first bead back into the bag. So this is sampling without replacement. And this is what most of you guys were used to in the questions. But there's our bag. It doesn't look very nice. I don't know, let's put a handle. But what is the probability of the first bead being, oh, okay, never mind. Let's change our bag. So from the bag, we have 3 red marbles. Let's put 3 red marbles. 1, 2, 3. And 5 green marbles. 1, 2, 3, 4, 5. Okay, cool. What is the probability of the first bead being red? So that means I'm about to take out a red bead and I'm not putting it back. So this would be 1, 2, 3. 3 out of 3, 8, if I'm not mistaken. Probability that the first bead is red. Okay, then put it back to the first bead, remove another bead, and then we record. Okay. So we can do the entirety of it, but most likely the first bead being red would be 3 out of 8. Okay, for this one part, guys. But I just want to see something, then without putting the bead back, the first bead, remove another bead from the bag and record its color. Okay. What would the probability? You know what, guys? I think I would prefer to actually do a tree diagram for this, just to make it a bit easier. I would prefer a tree diagram just to make it easier, just to show you guys what my probability part would be like, because I don't want to make it too difficult, but also I don't think you guys need to actually do it a very difficult way. We wasn't supposed to do tree diagrams right now, but let's just do it, right? This is red and this is green. Okay. This is red and green. For red, the probability is 3 out of 8. For green, the probability is 5 out of 8. That's for the first pick. Okay. Now, there is 2 choices here. So there's something we didn't realize. There is 2 choices. I think the tree diagram would be the best way to look at it, to visualize it. After the first choice, they don't put the bead back. So let's go and take out red. So once I take out the red diagram or the red bead, what happens is I got a choice to get red again, and I got a choice to get green again. So the choice to get red would be 2 out of 7. And the choice to get green would be 5 out of 7 because we did not put it back. Right? Now, the next one is if we go back and put the red back. If we go and put the red back, guys, so I'm going to explain again in a few moments. Let me just write out everything. I think it's a bit easier. This is red and this is green. Red would be 3 out of 7 and this would be 4 out of 7. Okay, let's go and explain properly. Let's go back and explain. My pen's not working. Okay. So let's put this bead back, right? Now, guys, the first chance, we got this person, and they say, okay, I want a red marble. So I'm taking out a red marble, and I'm putting it one side. That's fine, 3 out of 8. But if I wanted another red marble, I would have to take out another red marble, and my probability would be 2 out of 7, because there's 2 and there's 7 marbles. But if I took out a red marble and I wanted a green marble, my probability would be 5. 1, 2, 3, 4, 5. 5 out of 7. And that gets put back. Now we go back to the tree diagram, and we understand the probability of getting a green marble is 5 out of 8, because there's 8 total. But the moment you take out a green marble, the probability that you want to get a red marble would be 3 out of 7. That's why I got 3 out of 7. The probability that you would get another green marble is 4 out of 7. Now, the mistake of this thing is not reading the question properly to see that there was 2 choices. And this, for Shiloh, would be red, red. This would be red, green. This would be green, red. And this would be green, green. Now, guys, the question asked us very simply, what's the probability of getting red first? So when it comes to 2 choices, I can look at where do I have red first? And red is here and here. So that means the probability, I spelled first wrong, the probability of getting red first would be 2 out of 7. It would be 3. Let's go here and here. This would be quite easy. 3 out of 8 times 2 out of 7. 3 out of 8 times 2 out of 7. And let me try and sort this out quickly, just to make it easy. 3 out of 8 times 2 out of 7 should be 3 out of 28, if I'm not mistaken. 3 out of 8 times 2 out of 7. Guys, probability does take a little bit of time. Red and then green would be 3 out of 8 times 5 out of 7. So 3 out of 8 times 5 out of 7 would be 15 out of 56. Let's do all of them. It just makes things easier for me to answer, because later on I don't have to come back and keep saying red, green, all of the stuff. 5 out of 8 times 3 out of 7. If you watch the grade 11 video, you'll understand it was not fun. 15 out of 56. And 5 out of 8 times 4 out of 7. 5 out of 8 times 4 out of 7. And that equals to 5 over 14. Now, guys, you see, we got a problem, okay? Because we need to understand what this tree diagram asked and what this first question asked for. And without the tree diagram, even I got a bit confused. But they want the probability of getting red first. Where is red first? Red is first in these 2 examples. So the probability of getting red first would be 3 out of 28 plus 15 out of 56. And you can use the not plus. Yeah, we can use the calculator, and then we would get it first, right? But again, I don't think it's that difficult. I also don't think you guys should struggle too much. Let's get the probability of red first. 3 out of 28 plus 15 out of 56. And the answer equals to 3 out of 8. Now, if you're using the textbook, they would have did it in a different way. They would have started adding all the things up separately. It becomes very difficult. It is very confusing as well if we're going to mess around. But if we do this tree diagram and label the red, green, red, red, green, red, and green, green, and we start to actually add and multiply everything that needs to be done, the questions become easier. let's look at this, right? What is the probability of getting the second bead green? So they want the second bead to be green. Now that's quite simple. We can go to our tree diagram and we can look for the second bead being green. Now, if the second bead is green, all I can see is the second bead is green here and the second bead is green there. Why? Because there's it there, green and green. Right? So 15 over 56 plus 5 over 14. And that equals to whatever number you guys got, 15 over 56 plus 5 over 14. And that's also equal to 5 out of 8. Right? Now, the last one, what is the second last one? What is the probability of the first bead being red and the second bead being green? So the only time where the first bead is red and the second bead is green is here, red, green. So red and green, guys, I got no space to write question 2. I should have wrote it somewhere else, but let's just put it here. The probability of the first being red and then green would be 15 out of 56. Okay, so I don't think that's very difficult. I think it's fine to deal with. And the last one, are the first bead being red and the second bead being green independent events? Okay, so this one is difficult, right? So the first bead is green. Oh, the first bead is red. And the second bead is green. And we know this answer, right? We know this answer is 15 over 56 because they gave it to us. And is that equal to the probability of the first bead being red, which we know this answer as well because that's 3 over 8, multiplied by the probability of the second bead being green. And we know that answer as well because we calculated it, 5 over 8. And the answer is 15 over 56 does not equal to 15 over 64. So again, I know this question was difficult. If you guys did not do any of the grade 11 works, it's going to be a bit difficult. But with a bit of practice, right. Okay, guys, the next one, we got 2 questions left. We're going to start with this question. It says, the probability that a person drinks tea. Okay, so I'm going to start writing information exactly as they tell me. The probability of T is 0.5. Please understand they didn't say the probability of T only. They said the probability of T is 0.5. The probability that somebody drinks coffee is 0.4. They did not say coffee only. The probability that somebody drinks tea, coffee, or both is 0.8. Okay, cool. This one is a tricky one, right? But basically, they're telling you, listen, the probability that they're drinking any of this here is 0.8. So it took a while, but the probability of tea or coffee is 0.8. Right? And are we good? Determine the probability that a person drinks tea and coffee. Okay. Okay, we're fine. Let's go. It's a little bit complicated. I'm not fully... Yeah, but it's fine. T-A-O-B. Okay, cool. I think we can solve this without complicating it. That's probability of tea or coffee. I put coffee or tea, doesn't matter. Equals to probability of coffee plus probability of tea minus probability of coffee and tea. Now, guys, they want us to calculate this. This is what they really want, tea and coffee. And I think it's quite simple because you and I could work with 0.8 is tea or coffee which equals to the probability of coffee, which is 0.4, plus the probability of tea, which is 0.5, and minus the probability of coffee and tea. Now, this is just basic algebra. I would simplify this. This would be 0.9 minus P, C, and I don't know why I put A there. I'm thinking of A and B, but C and T, and 0.8. And if we solve this, probability of coffee and tea equals to 0.1. And we should end there. But what does it mean? It means that if I draw it, excuse me, it means if I draw a Venn diagram, which we didn't start it yet, but you guys did grade 11, so you can make it. If we draw a Venn diagram, looks like that. My circles don't look very good, but the probability of tea and coffee is 0.1. The probability of tea would be 0.5 minus 0.1, 0.4, and this will be 0.3. Okay, so now we're able to figure out that T only is 0.5 minus 0.1, and coffee only is 0. Let me use a different color. Coffee only is 0.4 minus 0.1 gives you 0.3. But basically, that's all there is to this question. Okay. Joe wants to open a tuck shop at his school, but he's not sure which cool drinks to stock. Before opening, he interviewed a sample of learners to determine what type of cool drinks they like. From his research, he determined the probability that a learner drinks cola is 0.3. Okay. Let's write properly, right? Because it's going to take some time. Probability of cola is equal to 0.3. The probability that a learner drinks lemonade, fancy lemons, lemonade is 0.6. The probability that a learner drinks neither, so none, is 0.2. Okay. Now we got a lot of information. Right? We got a lot of information. I don't have to draw a Venn diagram, but I am going to draw a Venn diagram just to make it easier for me. No one said that there's no, it's mutually exclusive. I don't think it would be. So, I mean, why would somebody not drink both? But I'm taking a guess for now. We're not supposed to really assume, but let's take a guess for now, just so I have something visual to look at. That's cola, that's lemon, that's 100. And none is 0.2. Okay, cool. So what that means is if nothing is 0.2, or I know the or answer, this cola or lemonade is 0.8, right? I noticed that because if people that don't drink both is 0.2, that means the or is 0.8, okay? So we're good there, right? I know this entire circle is 0.3. I know this entire circle is 0.6. I'm not writing it properly because it's not only, but it can be calculated. What is the probability that a learner drinks cola and lemonade? Okay. So firstly, I would need to find the probability of somebody who drinks cola or lemonade. And that's quite simple because I can go with 1 minus not, right? So I can go 1 minus 0.2, the probability of none. And I can complicate it, but a 1 minus 0.2 is 0.8. Now, guys, if you draw a diagram like what I did and try and figure it out, it works out very well. Because now we know that people that like cola or lemonade is 0.8. So the probability of C or L equals to the probability of C plus the probability of L minus the probability of C and L, right? And this should be simple. 0.8 equals to the probability of cola which is 0.3, plus the probability of lemonade, which is 0.6, minus the probability of both, which I don't know. Okay? And if we solve this, most likely, this is basic algebra, guys. That's 9 there. 0.1 equals to the probability of there and there. Okay, so this is 0.1. Guys, 0.3 minus 0.1 is 0.2, and 0.6 minus 0.1 is 0.5. So we just got the values. I don't think they asked us for it. But it just makes it easier for me to look at stuff. So the probability of cola and lemonade equals to 10%. Okay. The next question is the probability that a learner drinks only cola or only lemonade. Now, you and I worked this out. What's this? Only cola or only lemonade? Okay. Quite simple. The probability of cola only, let's deal with that. Let's put only cola, is equal to 0.2 plus 0.2, 20%, or whatever you want to say. And the probability that somebody only likes lemonade should be equal to 0.5, if I did not make a mistake, guys, because I could have made a mistake. And now the probability of OR would be very simple. How would we get the probability of OR? It's quite simple, because the probability of only, let's call it only C, and probability of only L equals to 0.2 plus 0.5, and 70% of the people like only. But if you had a Venn diagram, very easy to look at it and say 0.5 and 0.2. But these questions are meant to be done without a Venn diagram. But no one stops you, or nothing stops you from actually drawing the Venn diagram to answer it, because everybody's going to find something, some way different to answer. But okay.